All right, this is the third of the answers videos for the Day 27 Solutions 2 assignment. And so we're now moving on to problem 6A. And again, this comes from your college textbook, your AP textbook, page 542. So these are college level problems. So a solution, and let's just remind ourselves that the solute, which is the lemonade powder, and the solvent, which is the water, are mixed together to make the solution. Just keep that analogy in mind when you hear the words solution, solute, and solvent. Okay, so a solution is made by dissolving 3.5 grams of glucose in 0.1 kilograms of water. What is the mass percent of the solute in this solution? Okay, so it's always good. I want you to always write the general formulas out, and by doing that with every problem, it takes a little more time, but you end up memorizing the formulas, okay? So mass percent is going to be, okay, so now we substitute in what we have here. Now everything is in grams, nothing's in moles, so we don't need to make any molar mass conversions. So we're going to go with this. Okay, so we have grams of glucose. On the bottom we have grams of solute again. And then we have, the water is in kilograms. So whenever you have a plus sign, you can't just do one long nice equation like we're used to doing. So you have to just come down and do a side calculation of how many grams is 0.1 kilograms. And we have our standard conversion up here of grams to kilograms. So I'm going to come down and do that side calculation down here. Okay, so now that we've converted the 0.1 kilograms to grams, we can go ahead and plug it in there. It's 100 grams, so we're going to just come over here and do that. Just draw a line to separate this. And of course, I'm abbreviating glucose as GLU. We don't need to write the formula. And I forgot something very important for mass percent. It's times 100%. I'll put that there and there. Okay, right off your formula sheet. Again, you just always just refer to this as to what it's talking about. So there it is, grams of solute over grams of solution. We had to add the solute and the solvent together to get the solution, times 100%. And that gives us 11.9%. So 11.9% of this solution is glucose, and that's your answer. All right, so we're moving on to 6B, or excuse me, 7 rather. Now 7 says AB, but it's not. Let me show you the whole thing. It's not an AB problem. The B is not the same as the A with different numbers. It's really two separate questions. So I'm going to do the A question. I'll give you a little hint on how to do the B question, and then leave that one for you. Okay, so here we go. So an aqueous solution, again, aqueous means water. It means the solvent is water. And pretty much any solution we deal with in this class is aqueous. Of hydrochloric acid contains 36% hydrochloric acid by mass. Calculate the mole fraction of the HCl in the solution. So you got to remember this rule. I want you to write this down. I'm going to check this when you turn in your assignment. Okay. So we talked about this a number of times. When you are given a mass percent problem, you choose a sample size of 100 grams of solution. This will make the mass of the solute the same number as the percentage. So if we choose 100 grams of solution, we're going to have 36 grams of hydrochloric acid, okay? It's just the way it works out. So just remember that rule, and then you move forward, okay? So what we then have is, might run out of space here, so I'm going to put 36. Okay, so we have 36 grams of HCl over 100 grams of solution, and I'm going to actually have to write that as the solute and the solvent together. And the reason is we've got to get everything into moles. So grams of HCl has to go into moles. So it's going to be down here, instead of writing it as 100 grams of solution, I'm going to write it as 36 plus the remainder has to be 100 minus 36 is 64 grams of H2O. So let's stop for a second there. So if it's 100 grams of solution, the solution is made up of the solute right here and the solvent here. So that is 100 grams of solution. We know that 36 of it is HCl, so the remainder has to be H2O. It's similar to what we did up here with the sugar. That's the solution, but we had it broken into grams of solute and grams of solvent. Okay, so we're doing the same thing here. So what we need to do is do a couple of calculations. We need to figure out the number of moles in 36 grams of HCl. So I'm going to come way over here and we're going to write. Okay, so that gives us 36.46 for HCl. And water, I think we all know that, so I'm just going to write 18.02 grams per mole. It's the same up here, grams per mole for HCl. Okay, so now we have to figure out how many moles we have in 36 grams. And we're going to say that equals approximately 1. Okay, pretty close, 0.99 something. Okay, so that's HCl. Now we do it for water. 64 grams of water. And we're going to call that 3.6 moles of water. Okay, now I'm going to cheat a little since I'm not going to do this problem down here for you. I'm going to cheat and use some of the space. You might want to do this on line paper. Sometimes I don't leave you quite enough space. Really, it's because I asked you to write this sentence, but I do want to see that in the assignment, okay? So now we're going to just plug everything in. So mole fraction is chi, Greek letter chi. Let's write out the formula. You do that every time and you remember formulas. Now we plug in numbers. We have this for HCl. We have this for water. So the top is going to be moles of HCl. Notice I'm not putting the units on because everything's moles. Moles are going to cancel out. Mole fraction is always dimensionless. It doesn't have any units of measure. Okay, so this is what it looks like. And even though it's called mole fraction, it always appears as a decimal. And that gives us 0.22. If you did want to make it mole percentage, which you never do, it's always mole fraction. Don't ask why, it just is, because that's just what's needed in various chemistry problems. It would be 22%. So 22% of the solution in moles would be HCl, hydrochloric acid. Okay, now calculate the molality. So what is molality? Anytime you get one of these problems, they seem endlessly confusing until you just go and read the definition. It's moles of solute. Do we know that? Yeah, we just figured it out. It's right there, moles of solute over kilograms of solvent. Okay, well, we already have grams of solvent. Remember, it's not solution, it's solvent. So you got to convert that into kilograms using this. 1,000 grams equals 1 kilogram. Okay. All right. So again, this is all part of this problem. I'm coming down here. So I'll give you just this much, that it's moles of HCl, which we know right there, over kilograms of H2O. We know grams, so we use the 1,000 grams equals 1 kilogram conversion to get that into kilograms. Then you'll have your denominator, you already have your numerator, you're done with that problem. Okay, so I'm going to leave that one for you to do. You still don't understand? Come into tutoring and I will explain it to you, okay? Okay, we're on to number 8. All right, this says me, that's because I made this one up. You had a problem, in fact you had 2 problems just like this on the Solutions 1 assignment. It says your teacher tells you, that's me, if your teacher tells you I want you to make 0.5 liters of a 3.2 molar solution, aqueous solution of sodium hydroxide. So you've got to get the canister of sodium hydroxide and measure out how many grams you're going to need to do this. So I'm not going to do this one for you. I want you to see if you can remember how to do this. The only clue I'll give you is you need to end up with grams of NaOH over here. And over here, you don't start with the volume, you start with the molarity always, okay? So I'm going to start it way over here, 3.2. And now you have to break it out into moles of NaOH, the solute, over liters of solution. So you need to get from moles to grams there. You know what that's called. I'm not even going to tell you. You know what that's called. And then you have to get from liters to nothing down there. So you have a couple of conversions to do that. Okay, so this bottom is going to take 2 more conversions to make all the units on the bottom cancel out. Again, go back and review solutions 1 if you don't know how to do this, and I'm going to leave it for you to do. All right, and these are the ones I really check, are the ones that I don't do for you. Okay, another me problem, number 9. Okay, this is a dilution problem. When you see dilution, the word dilute or dilution, it means your lemonade is too strong, so you have to add water to make it weaker so it's not quite as sweet. That's what dilution is. So you have, these are the simplest ones. Go and look on your formula sheet for the dilution formula. Okay, there it is, way down at the bottom. Remember to make this correction. That should be V1. M1V1, molarity before you've added the water times the volume before you've added the water. So I'm going to write it again down here. Equals the molarity after you've added the water times the volume after you've added the water. It's pretty simple. It's just a simple algebra problem. Again, you have examples of this back on the Solutions 1 assignment. Okay, we have one last batch of problems. This one kind of does a little bit of everything here. All right, so first thing I ask you to do is compute the molar mass of malic acid. So I'm not going to do that for you. I'll just get you started on it. You have 4 carbons times 12.01 per carbon. Then you got your hydrogen. How many of those do you have? Then you have oxygen. I'm sure doing it in a really, well, I'm doing it in the right place. And then you have oxygen. How many of those do you have? And what is the molar mass that you get off? You got that from the periodic table. You get the other 2. And then you do all that. This one would equal 48.04. You figure out these 2, and then you add them up, and that's the molar mass of malic acid, okay? Okay, so number 10 I'm going to leave for you to do, and I can help you in tutoring either Monday or Tuesday before school and after school on Monday. Tuesday, not after school unless it's late, after my club is out. Okay, so first of all, molar mass of this. That should be automatic to you by now. All right? Molarity, I'm going to cross this one off. This requires what's called a simplifying assumption. I don't want to get you into that. In other words, it breaks the rules, but you say, it's close enough. It's one of those it's close enough things. But I don't want to go there right now. Okay, so I'm going to scratch that one off. Okay, molality. So just write down what molality is. It's moles of solute, and in this case the solute is malic acid. Now we don't know moles of malic acid, we know grams, and you're going to figure out the molar mass, so using that you can figure out moles of malic acid. Then on the bottom you have to have kilograms of solvent, and that's H2O. Well, that one's easy. You're given 500 grams of water, and you can use this conversion. 1,000 grams equals 1 kilogram to get you from 500 grams of water to some number of kilograms of water. Okay, So you're going to skip B, you're going to do A, you're going to do C, and then finally mole fraction. Okay, so what you're going to do is with that, you got to turn kilograms into moles. So that's a two-step process. So what you're saying is you've got some number of moles of malic acid for every 1 kilogram of H2O. So 1 kilogram. And you'll end up memorizing this number, but I don't expect you to memorize it, and that's not really the purpose of this assignment. You need to convert kilograms to grams, and then you need to convert so you convert 1 kilogram to grams using this conversion up here, and then you convert grams to moles, grams of water to moles of water using the molar mass for water. Okay, and that will get you to moles of water, and then from that you can figure out you have moles of water, you have moles of malic acid already, and so you can then figure out the mole fraction. You have to add the moles of water and the moles of malic acid in the denominator. Let's just go ahead and write that out. This is mole fraction. So again, you calculated the moles of water from 1 kilogram of water, okay? So that's going to require 2 conversions to do that, and then you just follow the formula and it gets you there. Okay, mass percent. All right, so mass percent is going to be, we have the grams of malic acid, we have the grams of water. This is the easiest problem, and it comes last. So it's going to be, let's just do it together and finish this, huh? So mass percent is going to be over the mass of the solution, which is this plus the water. And we have 500 grams of water. Okay, just do the math on that. This divided by these two things added together times 100. Forgot to do that earlier. Times 100%. Just times 100. Don't use the percent sign on your calculator. Don't ever use it. Times 100, and then you put the percent sign on the answer at the end. Okay, and that takes care of this assignment. So that's all the problems I'm going to do for you. Come to me for tutoring if you need help on this, and it's going to take some work in class on Monday and Monday night even to get this done. So this is due on Tuesday. All right, so we'll see you in class.